Hi all, let's go ahead and get started on chapter 4.3, solving quadratic equations by factoring. However, before we get started, I want to jump over to do some practice problems together that will help us there with our literal equations. So let's go to the bottom of page 3. It is the one that has the examples of factoring trinomials. It's got 2 examples on it. And what I've done is I've just broken up this page into like a third of the bottom. So go ahead and pause the video here and copy this down, please. Okay, let's go ahead and get started with these. Again, these are literal equations. They are formulas that we're going to be using. So what I'm going to do is take each of these and write them in a different form. Okay, so I'm going to take a plus b squared and I'm going to write it in expanded form. Excuse me. So for this first one, a plus b squared. Remember, that is saying our parentheses are being squared. So our grouping is being squared. So whatever's in one is also in the other. Okay. Using distribution, what we are going to do is take that a value of the first group and multiply it times the entire second group. Take the b value of the first group and multiply it times that entire second group. Now, many of you guys do this part in your head, but this first part, I definitely want to keep it so that you can see what I'm doing. So this is where you guys would say a times a times b. I'm doing that exact same thing here. I'm doing a times a and a times b. So that would give us a squared plus ab. Then I'm distributing the b to the entire group. So I have b times a and b times b. So when you're writing these, write them alphabetically. That will help us with the grouping. A plus b squared. Now I've got 4 terms. Looking at those 4 terms, I can see that these two here are like terms, so they can be combined. So that is a squared plus 2ab plus b squared. Okay. Now, when you notice on this that our first term is squared, our last term is squared, and then the middle value is double a times b. All right. So if the first number can be squared, or we can take the square root of it. If the second number, if we could take the square root of that, and the middle term is double those 2 terms, this is called a perfect square trinomial. Okay. So the shortcut for this one is, this is a formula here that we're going to be using. Whenever we see some number that is being squared, let me erase that, please. Whenever we see some grouping that is being squared, okay, and there we can take those and break it up into a squared plus 2 times the a times the b value and add it to b squared. Okay, so rather than having to do all these steps every time, we can do this instead. And that's some of what we're going to be practicing today. Okay. All right. I want you to pause the video and I want you to try to do these steps here that I did with the a minus b squared. Then I want you to come back and check your work doing all those same steps, but instead of a positive, this time there's going to be a negative. All right. Go ahead and pause the video. When you're done with that, come back and check. All right, so I'm just going to give you the shortcut answer on this one. So if you have, and I'll come back at the very end and work it out if you didn't get it. But your final answer on this one should be a minus b squared. So if we see one of these polynomials, but instead of being added, they're being subtracted, our shortcut on this one would be a squared minus 2ab plus b squared. All right, and like I said, if for some reason you didn't get that, I'll come back to that in just a little bit. Okay. All right, so let's go over to this one here where we have a plus b and a minus b. Okay, so even though there's still two groupings, they're obviously not the same grouping or they'd have them squared. So we're still going to use distribution on this one. So I'm going to take a times that second grouping of a minus b and positive b times a minus b. Okay, a times a and a times negative b, I get a squared and negative ab. Now the second one I'm going to distribute, so I would get positive ab and negative b squared. Looking at the two middle terms, they are both ab. However, one is positive, one is negative, so that means they actually cancel out. So we are left with a squared minus b squared. So the shortcut on this one, excuse me, the shortcut on this one is if they give us the values, the exact same values, and one is being added and one is being subtracted. So if we've got a minus b or plus b and the same values are being subtracted, then the shortcut here would be take the a value and square it, subtracted by the b value squared. Okay. All right, last one that I want to look at is if they give us a squared plus b squared. Okay, so the a value is being squared plus the b value being squared. There is nothing that we can do with this. There's no other way to write it, because even if I wrote a times a plus b times b, there's nothing more that we can do with that. We cannot distribute anything. So that simply stays a squared plus b squared. Okay, so the shortcut here, if you ever see these values where you have a is a number that can be squared and so is b, or a number squared, that there is prime. That's as far as you can go with that. There's no more factoring that you can do. All right, so let's go ahead and jump over to our notes and practice for this lesson. All right, going back to page 1. Okay. So you can still use the FOIL method. However, in class, we talk about distribution. Okay. So it's just that multiplying properties so that we can distribute these values just like we did with a times a plus b. Okay. I'm not going to go over this here, but keep in mind that distribution foiling is here in the box, talking about binomials, binomials meaning two terms. So if you wanted to FOIL those, again, it's distribution. So writing a quadratic equation in standard form and with negative 1/3 and 6 as its roots. Roots is the same or similar vocabulary to zeros, x-intercepts, solutions, right? So you can hear any of those words. This is just a new one to add to our vocabulary bank, or roots. All right, so writing a quadratic equation, they give us the values. They tell us that x equals negative 1/3, because that's one of our roots. And the other root is x equals 6. So to write them in standard form, first thing we need to do is we need to take this negative 1/3 and move it to this side. and this positive 6 and move it to the other side. So we've got x plus 1/3, and we have x, don't need that parenthesis there, we have x minus 6. Okay. By writing it that way, these both equal 0. So if we had to solve it, whenever we want to solve it, we want to set it equal to 0. So now we have two groups here. Our first binomial is x plus 1/3, and our second one is x minus 6. So we're going to take those two binomials and multiply them together. All right, so let's go ahead and practice two ways that we can distribute this. The first one I'm going to use is the area model. Now, this is similar to what you guys had talked about using this in science as Punnett squares. Okay, so this model is probably familiar to a lot of you. The first one is x and positive 1/3. Over the top is my second binomial, x and negative 6. It doesn't matter which binomial you put where, okay, just as long as you keep each pair together. All right, now using our distribution, we would talk about x times x. That gives me x squared. X times negative 6 is negative 6x. 1/3 times x. And 1/3 times negative 6. All right, these two here are like terms, so we can combine those. So when I rewrite this out, I'm going to write this first term, the two middle terms combined, and then the last term. So I have x squared. When I combine those two middle terms, well, let me just write it out here first. 6x, negative 6x plus 1/3 x, and then minus 2. These two here are the ones that I'm combining. When I combine them, I get x squared minus 17 over 3x minus 2. Now, for those of you guys who don't like fractions, we talked about if you wanted to get rid of that fraction, we would multiply this whole trinomial times the denominator, that common denominator of 3. And then we get 3x squared minus 17x minus 6. Okay. All right. So that is using the area model. Now I'm going to do the same values, but this time I'm going to use distribution. All right, so distributing x times x, or I'm doing x times x minus 6, and then we're doing positive 1/3 times x minus 6. That's what the property we're actually doing when we do distribution. However, again, if you just said x times x, you would get x squared, x times negative 6, plus 1/3 x, and then negative 2. Okay, if you see here that you have a fraction and you don't want that fraction, go ahead and multiply this entire thing times 3. Okay, if you don't want to look for those common denominators, then you would get 3x squared minus 18x plus x minus 6. Combine those two there, and you would get 3x squared, not 7th, 3x squared, minus 17x minus 6. Okay. Either way, we get the exact same solution here. All right, so let's scroll down to example 4.32. All right, solving quadratic equations by factoring using the zero product property. We brought in a new keyword here, and this is solving. So whenever we're solving, we always want to set the equation equal to 0. That's the first step. Set equal to 0. We always then want to look for a GCF. Look for a greatest common factor, something that we might be able to factor out so we can deal with smaller values. Okay? All right, my example here looks a little weird, so I'm going to rewrite it off to the side. Yours should be fine on the worksheet, but mine came out kind of wonky. So 16x squared plus 8x equals 0. Okay, step 1 said always set it equal to 0. Well, they've already done that. It's already set equal to 0. Step 2 says look for a GCF. Is there anything that these two terms have in common? Well, in this case, they both have, they can both be divided by 8. And they both have at least one x. So their GCF is 8x. So when I say they're dividing it, we're not reducing it. We still need to show that there was an 8x there. So we have to factor out that 8x. That 8x is just going to go out in front of the grouping. So we're undoing distribution. So 16x squared divided by 8x leaves me with 2x. And 8x divided by 8x leaves me 1. Okay, so I've got 8x times 2x plus 1. Now again, to solve, that means that I still have to keep working to get x by itself. All right, using the zero product property, we talked about this in class. Anything times or two binomials multiplied together, or two terms being multiplied together, if I want their answer to be 0, then one of them has to be 0. So what I'm trying to find out here is what can I plug in for x to make this 0? Okay, so if I had 8x and I set it equal to 0, solve for x, dividing both sides by 8, we get x equals 0. Okay. Well, if 8x isn't 0, maybe our binomial is 0. So then we have 2x plus 1 equals 0, which gives us x equals negative 1/2. Okay, so there are our two solutions when we're factoring. X equals 0 or x equals negative 1/2. All right. So let's go on to the third page. Trinomials and binomials that are perfect squares have special factoring rules. Those are those special factoring rules that we talked about when we began this video. Okay. So in order to use the rules, the first and the last term need to be perfect squares, and the middle term needs to be twice the product of the square roots of the first and last term, or in other words, twice a times b. Okay, all right, so a perfect square trinomial is a number with a positive square root that is a whole number. Okay, so what is a perfect square trinomial? Well, it's a binomial squared. Now, before we do that, though, there are some pieces of information that you need to know. You've got to at least have these down somewhere in your notes or something along those lines. So if I said, what is the square root of 4? That's 2. The square root of 9 is 3. The square root of 16 is 4. and so on. So I'll write down as many here as I have room for. So we want to know these binomials, or these perfect square values. Okay, 64, 81. All right, so these values are going to help us, plus others, but let's start with these. So solving each equation. So first off, make sure it's set equal to 0. Second, make sure there's not a GCF that I can factor out. And this is where I'm going to check if I could possibly take the square root of x squared. Well, sure, I can, and that would be x. Okay. Can I take the square root of that last term? Yes, the square root of 64 would be 8. These two here, I would have to do 2 times x and 8. And that looks a little weird, so I'm going to write that as 2/8x. 2 times x times 8. All right. So if we can do that piece there, then using our shortcut, okay, going back to what you guys had at the bottom of page 3, we're going to have x plus 8, and we're going to square it. And that is our answer. Okay, but we have to be sure that we can take the square root of the first number, the square root of the third term, and that the middle term is twice the value of a and b. All right, looking at b. This time we have to first get it set equal to 0. Okay. So we are going to take x squared minus 64 equals 0. Okay. Looking at the first term, can we take the square root of that? Yes, it is x. Looking at the last term, or the constant term, can we take the square root of that? Yep, that would be 8. Now, looking at our rules, whenever they're being subtracted, and I'm going to go down and look at that. So I have x squared minus 64, so a minus b. This one here, whenever we have a minus b, okay, whenever we have that a minus b, it's going to be the same thing, but this time it is going to be that negative b squared. Okay. So, and I know ours doesn't have a middle term. So let's get back to that. Okay. So we are going to have on this one x minus 8 and x plus 8. Okay. If you're ever not sure, go ahead and use distribution again. So if you did x times x, x times 8, negative 8x, and negative 64. These two here would cancel out, and you'd be left with x squared minus 64. Okay? All right, so let's go on to this next section. A special pattern is used when factoring trinomials of the form ax squared plus bx plus c. First, we would multiply a times c, then find the two values, they call them m and p, that produce the equals a and c, that adds up to b. That is kind of wordy for what we practiced in class. So if you remember, in class, we practiced using this diamond method. Okay, we said what two numbers will multiply what two numbers would multiply to that value of a times c and add up to b? We practiced that whole worksheet on this, and I've even left some for you there while I'm gone that you're supposed to be practicing each day. So theirs is they took 6 times negative 5, and they were looking for everything that multiplies to negative 30. They've listed all of them here. So they said 1 times 30, 2 times 15, or negative 15, 3 times negative 10, 5 times negative 6. Then they also said, well, what about negative 1 times 30 or negative 2 times 15? And they did so on. Now, once they found all the factors, they decided, well, what if we were to add or subtract them? If we found their sum, what would it equal? In this case, this one equals negative 29. This one equals negative 13. So let's try this so that we can see what we'd come up with. So if we had negative 30 is a times c, and our b value was 13. Which of these two values would multiply to negative 30 but add to 13, or which of these two factors? So that would have, or positive 13, that would be negative 2 and positive 15. So we would put in negative 2, positive 15. Now that's as far as we got with practicing with that. So what we are going to do is take these two values here, and we are going to write them into our equation so we can get it factored out completely. Okay, so that's where we're going to go from here. So they've taken that negative 2 and that negative 15, and they filled them into their, or negative 2 and positive 15, and they've written them into their equation. They grouped together the first two, grouped together the last two. Then they factored out a GCF of each one, and they set their binomials. So they took this equation here, that was 3 terms, okay, and they rewrote it as this here. Okay. And that's what we are going to go practice now. All right? So, factoring trinomials. All right, so what we are first going to do is look for those values that multiply to a times c, but add to b. Okay, so 1 times 20, but add to 9. All right, so we can think of all those factors. Well, there's 1 times 20, 2 times 10, and 4 times 5. Okay, so for us, in our case, we're going to use 4 and 5. They're both going to be positive. 4 times 5 makes 20. 4 plus 5 makes 9. All right, so rather than combining like terms, we are going to break it apart. So we're going to take this middle term and we're going to break it into 2 pieces. So we're going to have x squared, our first term, and instead of 9x, we're going to have positive 4x and positive 5x, and then we're going to keep that last term, positive 20. So what we've done is we have factored, or we've factored 9x. We're breaking that apart into 4x plus 5x. So usually we combine like terms. We would say 4x plus 5x equals 9x. Now we're undoing that. We're breaking that into 2 other terms. Okay. So once we've got those 4 terms, we are going to group them together. So this is factoring by grouping. So group together the first 2. Okay. Group together the last 2. And then we have the first one, we want to look for a GCF. So that GCF of that first one is x, and I'm left with x plus 4. The second binomial has a GCF of 5, and I'm also left with x plus 4. Okay. So if you look at this, what we're seeing now is that these two terms, so here's my first term, here's my second term, they both have x plus 4 in them. So we are going to factor out or divide out. Imagine this is like another set of parentheses. We are going to factor out x plus 4, what they both have in common. Okay. Just like when we did one earlier where we had to factor out the 8x, on this one here, we've factored out x plus 4, and what's left on the inside of the parentheses is x plus 5. Okay, so that is factoring by grouping, right? All right, so let's go do example B together. Okay, first thing with example B, I want to look to see if there's anything that 6, negative 23, and 20 have in common. Is there a GCF? But there is not. There's nothing that I can break them apart with. So we're going to first go ahead and start with our diamond. We're looking for the numbers that multiply to 120 and would combine to negative 23. Okay. So let's go ahead and list those factors. 1 times 120, 2 times 60, 3 times 40. And I'm going to check those first three to see if either of them work, which in this case, none of them work yet. Right? Then I've got 4 times 30. And I've got 5 times 24. And I've got 6 times 20. Okay, checking those three to see if any of those work yet. Still none of those work. Okay, so we've got to keep looking. So if we took 120, and you can just keep working along the way, and 120 divided by 7, well, that would give you a decimal. What if you did 120 divided by 8? Okay, so you'd get 8 times 15. You could try 120 divided by 9, and that one wouldn't work for you. But then you can also think of, what about 120 divided by 10? Well, that's 10 times 12. All right, well, let's check those two. Will either of those combined, whether we're adding or subtracting them, give us negative 23? Yeah, 8 and 15 would give us a positive 23. So let's try those ones. 8 times 15 makes 120. But 8 minus 15 does not, or 8 plus 15 doesn't give us 23. What if I made one of them minus? Nope. So in this case, they both need to be negative. Okay. All right. So once we find these two factors, and that will get quicker as we go along. Okay. But once we find those two factors, we're going to rewrite our equation. But instead of negative 23y, oops, that should be an x. That should be an x there. Instead of negative 23x, we're going to break it apart into negative 8x and negative 15x. We're going to put these two values in place of negative 23. All right, so we've got 6x squared minus 8x minus 15x plus 20. Okay. So we've taken a trinomial and we've made it into a polynomial with 4 terms. Go ahead and group together the first two. Okay. This is negative 15, so it's like adding negative 15. Okay, so we're going to group together the negative 15x plus 20. Make that negative a little bit darker. All right, so then we've got 6x squared minus 8x. They can both be divided by 2x. So I've got 2x. My GCF, or what's left over, is 3x minus 4. And the second group, we always want this first one to be a positive. Okay, so if there's a negative in front of it, I'm going to want to factor out. I'm going to put needs to be positive. We need to factor out that negative. So I'm going to divide both those terms by negative 5. Because they are both divisible by 5. So then I'm left with a positive 3x, negative 4. All right, looking at these two, what they have in common out of these two terms, this term and this term, they both have 3x minus 4. And what would be left is 2x minus 5. Okay. All right. So that is it for these notes. I want you guys to go on to the very last page for some practice. Oops, I have a double copy of that page. So on this one here, I want you guys doing number 1 and number 2. I want you guys working on number 4 and I'm going to do 4, 5, and 7 in this case. Okay, we'll talk about number 6 when I get back to class. Number 8, I want you guys doing 8, 9, and 10. Okay, remember I always set it equal to 0 first. And then we'll talk about 11 and 12 really quickly. It is saying this is a square. So your binomials on this one are x plus 2. Remember, it's always length times width times x minus 2. Okay, so on this one here, they want you to create a trinomial. Same thing on number 12. So I want you doing 11 and 12. All right, let me know if you have any questions.